Hey, Vlad here, devinsidey.com. Welcome to another video. In the previous two videos, we talked about the two most important topics in the object-oriented world: subtype polymorphism, which allows for dependency inversion or inversion of control, and inheritance, which allows for modular design and also code reuse, even though code reuse is kind of being frowned upon lately. Anyways, today we're going to talk about traits and all the cool things that you can do with them. Well, not all the cool things, but most of them. As always, we're in the Ubuntu virtual machine and we have Sublime on the left as our text editor, and we have a regular terminal on the right which runs SBT inside of it and runs our code as soon as we save. Now, before the intro, I mentioned that using inheritance for code reuse is being frowned upon. There's a very famous book in the Java world called Effective Java, written by Joshua Bloch, which dedicates an entire chapter to this topic alone. It's called Favor Composition over Inheritance. Now, traits, among other things, allow you to express composition over a concept which is very, very similar to inheritance, in particular to multiple inheritance. And the official name is mixing composition. So thus you mix in behavior into your object. You mix in traits into your object. By the way, the first time I learned about traits, I didn't really know what the word means. And if you're in the same situation, then have no fear, Vlad is here. So a synonym for traits is characteristic. So if you have a trait with a few attributes that characterize something, you can mix this trait into your object, and this object will thus have access to those attributes. In this way, different aspects of classes can be encapsulated in different traits, which allows for very modular design. All right, the first thing that we need to talk about is the difference between thin and rich traits. So a thin trait is very similar to Java's interfaces. In traits like this, most methods, if not all of them, are abstract, and rich interfaces are sort of the opposite. Most methods in a rich interface are implemented, usually in terms of the abstract methods. Let's have an example. So we're going to have a very simple hierarchy. We're going to have a trait called pet, and it's just going to have one method called allowed to sleep in bed. And it's a very thin trait because it's just going to have this one method and it's going to be abstract. Then we're going to have a class cat extends pet. Let me remove the cursor. And it overrides with a val, by the way, just because we can, this method with true, because a cat can sleep in bed. And now we're going to have a turtle, and it also extends pet. Now we're going to use a def just because we can. There's no particular reason. And a turtle shouldn't really sleep in bed, right? And now we're going to have a function called show, which we're just going to take a pet and return a unit, and it's just going to print line pet dot allowed to sleep in bed. And now we're going to call show one time with a cat, and one time with a turtle. And if I did everything right, then we should see true and false. Now, we've seen already that a trait and an abstract class in most cases are pretty much interchangeable, but in this video I want to concentrate on the fact that traits are used to mix in behavior. So just for visibility reasons, we're going to have a class called animal, and instead of extending a pet over here with a cat and a turtle, we're actually going to extend animal first, and then we're just going to mix the pet in. So the results should stay exactly the same, but just because it's just so that it should be more visible, that it's sort of traits sort of feel like they're coming like from the side. They're sort of like mixed in from the side. They just throw in a few attributes in your object, which is kind of cool. So the next thing that we're going to do is we're going to convert this thin interface into a rich interface. So basically we're just going to define another method called disallowed to sleep in bed, which is not an abstract method. It's just defined in terms of this one, allowed to sleep in bed. So it's just going to say, I'm going to put it here, not allowed to sleep in bed, right? And now all of a sudden, cat and turtle, they should have access to this method, right? So we can switch it to the disallowed one, and now it should swap them, right? Now it should be false and true, which is kind of cool. So this is basically the difference between thin interfaces and rich interfaces, and there's nothing more to it. Now, traits can do many things, but I prefer to divide them into 3 separate categories. The first thing that the traits can do is they can add functionality, as we've already seen, but we're going to have another example in a second. The second thing that they can do is they can modify functionality, and we will actually see that you can have different kinds of modifications and you can use them all together, you can stack them all together. And the third thing that they can do is that they can intercept functionality, which is very similar to modifying the functionality, but we're going to have an example later. So the later two categories are a bit more involved. So before we jump there, let's just have another example for just adding functionality so that it just sinks in a bit more. So for that, I'm actually going to leave this stuff over here so that we just have it for reference, just in case. I'm going to remove the shows because I don't want to have those print lines. So we're going to use the Java file API. It's called file, by the way, but it stands for path. So we're just going to have a path of a file, and the file is going to be exactly this file where we're in right now. So if you see, it's in my home folder in dev, Scala playlist, source main, and so on. So I'm just going to say home lad dev. In fact, you know what, Sublime allows me to do this. Copy file path, and now I can just paste it in. So it's home vlad dev Scala playlist source main Scala main.scala, right? So now we're going to use the Java API for path, which is called file, as I already mentioned. So I'm going to say file equals new Java IO file, and I'm going to pass in the path as an argument, right? And files have a bunch of methods, like for example, we can print out the file name. Let's see that. So this is not really spectacular. So let's say that just for fun, we want to have a trait that allows us to access a single variable inside of this trait, which is going to be called creation timestamp. And the idea is that we will be able to take this trait and then just to mix it in any class that we want. And in this case, we're playing around with files, so we're going to mix it into the file. And then we want to see when this variable was basically created. So it's not like when the path was created. It's basically this line. When was it invoked? When was the new invoked? So let's add this trait for now. So we're going to call it timestamp, and it's going to have a single val creation time, and it's just going to be a string, just for simplicity's sake. And we've already seen how to retrieve the time in a lot of my previous videos. I'm starting to feel like I'm sort of obsessed with time. So that's how you do it. Now dot format, and you pass in a formatter, and the formatter is going to be defined over here. Formatter equals Java time format dot date time formatter. Right, there we go. Of pattern, and the pattern is going to be hours, minutes, and seconds. So unless I made a typo somewhere, no, it's fine. Okay, so now what we can do is we can create a separate class. So we're going to call it class file with timestamp, and it's going to have a constructor, which is a path, which is a string, right? And we're going to extend the Java IO file. And the line is getting kind of long, so I'm going to do this, and I'm going to put the terminal down. And from the past, I know that we're going to need more hyphens for that to look really cool. All right, so we have file with timestamp, accept a path in its constructor, extends Java IO file, and the Java IO file also accepts a path in its constructor. So we have to just pass it along. And we've never seen this syntax before, but this is basically how you do it. You just sort of chain constructors, right? And now we mix in the timestamp, right? We call it timestamp, right? So now everything should compile. Yeah, it compiles. So now let's try to create a file like this. So we're basically going to say new file with timestamp, and we're going to give it the same path. So this in our case, it's this variable over there. So we're not going to create this file anymore, and we're not going to do this print line. Actually, you know what? I'm going to move the path down. I'm going to move it over here, right? And I'm just going to remove this and this and this, right? So now we can still say file.getName, right? And we should also be able to say file dot, how do we call it? Creation time. File dot creation time, and we should see the time when it was created, right? And it's the same time because it's a val, right? Usually when we play with time, we would like pause the current thread, and we would run it like every we'll pause the current thread for like a second, and we'll run it in a loop, and we'll see that it refreshes all the time. In this case, this is the opposite of what we need. We need it to be frozen, right? So it's a val. So if I print it out a few times, it should always show the same thing, because it's the time when the object was created and not the current time, right? So we're going to talk about the types a little bit right now. So instead of just printing out them like this, I'm going to put them into separate methods. So this one I'm going to call show name, and it's going to take a file, right, unit, and it's just going to do a file dot get name. Whereas over here, I'm going to say show creation time, right? And now what I need is anything, right? What's not actually anything. I want a timestamp, so I'm just going to call it timestamp with a lower t, timestamp of type timestamp, right? Unit equals, and now I just need to use timestamp creation time. So basically a file, what did it do? All right, I need to do java.io file, right? There we go. So yeah, of course, I forgot to actually call them. So get show name was a file, and we're gonna have show creation time also with a file. So we already know because we already know how inheritance works. We know that a file basically has two types, right? It is a file and it is a timestamp. So I just demonstrated that just to show you that you can also use anonymous classes, and I'm going to have a dedicated video just for anonymous classes because we stumbled over them already a few times in my previous videos, and I'm sort of like explaining them bit by bit, and I think I should make a video like really soon about anonymous classes. So what I'm going to show you is that creating this class, which, remember, I told you, like whenever you create types in the Java ecosystem, because Java has a nominal type system, creating a class basically means giving a name to something. Like in this case, giving a name to some structure, giving a name to some type, right? But with anonymous classes, there is no need to do that. And the anonymous classes are usually used when you have only one instance. So what I want to do here is, instead of instantiating this, actually, you know what? I'm going to duplicate this, and I'm going to do this. So instead of doing that, I'm going to do new java.io .file. So I'm still, doing the file like we used before, and now sort of on the fly, I'm saying with timestamp. So basically, I end up not needing this class. Okay, let me remove that. And actually, I'm not going to remove it. I'm going to comment it out. Right, I'm going to comment out this as well. So now it sort of works. So it's basically saying like, okay, we're extending the Java.io file. So there's basically a class here, right? So we could also like add methods here. Show unit, right? Print line hi, right? And then we're saying with timestamp. If I did everything right, it should work. Okay, maybe the syntax is actually like this. That was saying with timestamp, and then the body's coming. Yeah, so this is how the syntax works. So now we can actually say file.show. So we're basically creating another class on the fly, and then we're creating another instance of this class. Not another instance, the only instance of this class, right? Because this class doesn't have a name, so we can't create more instances of it. So we're creating class, and we're creating an instance of it at the same time on the fly. Now the question is, and let me remove this whole show thing. The question is now, what is the type of file, right? Because if we just say file, let's see, if we just say file, then something is not going to compile. Now because of that, hold up, java.io.file, this is not what I meant. I meant this. So now when we're trying to pass show creation when we're trying to pass file to show creation time, what ends up happening is that Scala thinks that this is just a Java.io file, but in fact it's something more. It's just that we didn't allow the type reconstruction to do its job, the type inference to do its job. We basically sort of ruined the type, right? We made the type less specific. So now Scala is not sure that timestamp is there. And the other way around, if we use timestamp here, then we're going to have the problem with show name. And this is also the reason why I created them, huh? Right, so the question still remains, what is the type then? Well, the type is java.io.file with timestamp. This thing is a type. And because we're sometimes lazy to type, type, we're going to create a type alias. And we're going to call it too lazy to type. and the value is going to be this, right? And now I can just use this name, right? In fact, just for fun, we could also do this. So this was a tiny excursion into anonymous classes. Now, before we move to the next section, I want to say one tiny thing about this. Now, I mentioned that traits, they sort of feel like they're sort of coming from the side, but behind the scenes, there's still some inheritance involved. So what I'm trying to say is that you can't do this if the class that you mix something into it, if the class is declared as final. So if you can't extend this class, then you also can't mix anything in. In fact, let me show you have an example. So string literals, right? So we can do hello world, but what we can also do is, and in fact we're going to get a warning that we're not doing anything with it. So instead of just saying hello world, I believe we can also do new string hello world, because there's actually a class called string, right? Yes, it still works, but the problem is that the class string is actually final. So we said that we can mix timestamp into anything. Well, let's try that. Let's do val blah equals new string of hello world with how do we call it? Timestamp. Yeah, we call it timestamp. So this should not compile, because it should tell us that it's an illegal inheritance from final class string, because class string just happens to be final, which is a good thing, by the way. The next category on the list is modifying functionality, and as I already mentioned, we can have multiple traits, so we can have multiple modification traits that can be stacked on top of each other, which is a really cool pattern. In this pattern, which is called the stackable modification pattern, by the way, there are three kinds of elements. There is a base trait or an abstract class, and in our example we're going to use an abstract class. There is a core implementation of this abstract base class, so basically there is a class that extends this abstract class, and in our example we're actually going to have two cores just because we can. And then, well, you have the modification traits. So in our example we're going to build a tiny simulation basically for a racing game. Forget that I said simulation. We're going to build a tiny racing game. So for that, actually we're gonna first of all, we're gonna let me remove that just so that it compiles. Right. So what I'm going to do now is I'm going to maximize Sublime, because we're gonna do a lot of typing before we actually try to compile anything. So let me create some more files. So we're going to create a file called I'm just going to save it. It's going to be an empty file. I'm going to call it base.scala. Right. Let me actually put an object in there. I'm going to call it base. Now I'm only creating those objects just for readability purposes. Okay. So we're going to have base. We're gonna have not a folder. We're gonna have a new file called core, and let me also create an object core, and we're gonna have a file called modifications. No, let's just call modification. All right. So over here we're also gonna have an object modification. Right? Okay, so as I said, in our example, we're going to build a racing game. So we're going to start with our base, and base, as I already mentioned, it's going to be an abstract class or a trait. In our case, we're going to use an abstract class. So because it's a racing game, well, obviously we're going to talk about cars, right? And a car is going to have a model, and it's going to have top speed measured in kilometers per hour. And we're going to have top acceleration measured in revolutions per minute, which is also just an integer. And we're going to override a method called toString, and we haven't talked about this yet, but we're going to talk about this in a future video where it comes from. In fact, we're going to mention it a little bit here in this video, but we're not going to go in depth. So basically, every object has a method toString that can be overridden. So we're going to say override def toString, right? And its type is string, and it's going to be, so first we're going to calculate the brand, and the value for brand is going to be getClass.get simple name. So the same as every object has a toString method that can be overridden, every object also has the method called getClass, and I'm going to mention a little bit more about this in just a few minutes, and I'm going to go in depth in another video, right? So now we're just going to concatenate a slightly longer string. So we're going to have brand plus just an empty string, plus model, plus space, plus top speed, plus and top acceleration. All right, so our base class should be complete now. In fact, let me minimize Sublime a little bit. Yeah, it still compiles. All right, it compiles, and actually it still runs whatever we have in our main. So now actually, you know what? I'm gonna split the screen, split Sublime into 4 parts. So I'm gonna have the base here. We're gonna have the core. In fact, you know what? I'm gonna put the core down because the core is going to be extend the base. So it's actually kind of cool. And then over here we're gonna have the modifications. So let me put the modifications to the to the second one over here. Right. So the next thing that we're going to do is we're going to have a core, and usually it's one class, but in this case we're going to have 2 classes just for fun. Okay. So we're going to have a class called ordinary car, right? And this is another syntax that I haven't showed you yet. So we can override something in the constructor. So this is an abstract method called model, right? What we can do is we can say, okay, this is a class, but in the constructor I also want to get the model in, right? So in the past, for example, was a file. Remember when we were extending file, actually let me write right over here. So we did something like class file with timestamp. It was getting the path, right? And it was saying extends java.io file, and it was passing the path over here, right? And then we'll say with timestamp. Now over here, we don't have the base class that has a constructor that accepts something, right? But it doesn't mean that the implementation, you know, that the extension of the base cannot accept, in this case, the path, or in our case, the model in the constructor. So in our case, well, what you can do is you can say override right here, override val model. You know, we already know that in the constructor you can't have a def, so we're overriding with a val model, which is a string, right? And then we say extends base dot car, right? And again, the car doesn't have a constructor, so we can't do this. So compare this to this, right? So we can't have this, but because we have an override, it knows that it's the override for the model. Okay, let me remove that. Okay, so it extends a car, and now we need to override, or basically have to implement all of the others, right? So we're gonna override, and by the way, in this case, we actually can't override these vals because you're gonna end up having problems with this whole pattern. You can try it out later if you want. I don't think that I'm gonna mention it in this video. So the top speed in kilometers per hour for an ordinary car is going to be 220. You know, it's still a racing game, right? So even an ordinary car is something like, you know, like a BMW, or, you know, an Audi or something like this, right? So it's still a racing car, so it's 220. Okay, I'm gonna try to make it as realistic as possible. Okay, and by the way, just for fun, no, actually I'm gonna say this in a second. Hold on. Let me override the other one. Let me override the top acceleration in RPM. Whoops, like this, and the revolutions per minute is going to be 8,000. So now everything is there. So I'm sorry, I didn't want to do that. I wanted to minimize Sublime, right? So everything still compiles and everything's still running. So what I wanted to show, like a second ago, that first of all, remember, this is an abstract method, so we don't need to use the keyword override. So in fact, let me actually do this. So in fact, if I remove override, everything's still going to work, and also you don't have to specify the type. But I highly suggested that they actually do specify the type, because you sometimes run into issues with type inference. For example, if there was a class that extends int, the type inference would infer the most specific type, and usually this is not what you want. Usually you want to maintain the signature, so usually you would want to maintain the base type here, right? So in my examples, and you know, I'm in the business of education, right? So I'm always going to try to specify the types, and I'm always going to, you know, try to specify you know, rather more things than less, even though Scala can, you know, infer a lot of things. All right, so we have the ordinary car. And as I already mentioned, we're also going to have another core class. We're going to have class sports car. Sports car. It's going to look exactly the same. In fact, you know what? I'm just going to do this. Right? So we have a sports car now. Sports car. Right? And it's just going to have different numbers. So it's a bit faster. And it also can go higher with the revolutions per minute. So if I did everything right, then it still should compile. Yeah, it compiles. So now we're going to talk about the modification traits, and this is where actually the fun begins. So we basically have things that we can literally bolt on to the car. So we're going to have 3 modification traits, and the first one is going to be called a spoiler. So you can put a spoiler on a car, right? And we're going to try to override def this one. So as soon as you add a spoiler to the car, you want to make it a little bit faster. But the trick is we don't want to add just a constant factor, right? We just want to say, okay, as soon as you put a spoiler in, it's going to be 50 kilometers per hour faster. This is not how it's going to work. So we want to have a reference point. We want to have a reference point of whatever was there before, right? So this is still an integer, right? And over here we want to say super dot top speed in kilometers per hour just a bit faster, right? So we just want to add 2% of the speed, right? And this is when we do times 1.02, there's always going to be a double, so we now have to convert it back to int. But now we have a problem. So if I'm correct, oh, first of all, not found the type car, right? Because we need to say base.car. Right, okay, and this is exactly why we're here. So it says method top speed in kilometers per hour in class car is accessed from super. It may not be abstract unless it is overridden by a member declared abstract and override. So we're trying to override a method that is abstract. And Scala has a way to solve this and basically tells you how to do it. It says, okay, you don't just need an override, you need an abstract override. Abstract override, and now it should work, right? So this is a feature that is not common to a lot of languages. It's very, very rare. And in fact, I remember when Scala came out, there were some people in the Scala community who were saying things like, oh, the first time I saw this, I thought it was a bug, right? Okay, so we're gonna have 2 more traits, 2 more modification traits, but in fact, just in this example, because I wanted to make it more fun, I'm gonna allow them to be mixed in only into the sports car, right? And because a sports car is not an abstract class, we actually don't need abstract override, but we can still use it. So let's do this. So we're gonna have an engine control unit extends ordinary car. Yeah, I actually made it the other way around. So I said we're going to restrict it to be able to mix it only over here, but in this case, we're only should be able to extend the ordinary car. So an ordinary car can have an engine control unit, but a sports car is already too fancy. There's like no space for an engine control unit. By the way, I'm not a mechanic. I have no idea what I'm talking about. But let's just assume that I'm right. So we can also do, as I said, we can also do an abstract override, but there's no need. There's no need because in the ordinary car, there is actually already a definition for top speed in kilometers per hour. So we can just say a regular override. So we're going to override, and in this case, we're going to override the same thing. And in fact, everything's gonna look super similar, right? Like this, and it's gonna do super dot top speed in kilometers per hour. And an engine control unit actually can do a bit more. So it actually gives you 50% more, right? 50% more, that to int. Let's see if it compiles, and it does not because I forgot to say base.ordinary car. Base.ordinary car. Let's see. It's not a member of object base. All right, it's not base, it's core. Why did I say core? Oh yeah. Why did I say base? Yeah, because here I was just copy pasting it, so my eyes were just like kind of busy. Right. So this is also another indication. You see, like where this trait spoiler, it extends something from base, which is why it needs the abstract override. But this one, it extends something from core, so it doesn't need the abstract override. Okay, and the last one is going to improve the top acceleration in RPM. So it's not going to improve the top speed in kilometers per hour. So we're just going to do the trait, and it's going to be called a turbo charger. Extends core dot ordinary car, right? And in this case, it's going to override def this one, this one, and it's going to be an integer, and the pattern is very similar. We're going to take this and we're going to improve it by 25%. What's wrong with me? 25%, and we're going to convert it to an integer, and that should compile. Everything should compile now. Right, so the next thing we're going to do is I'm going to actually take main and I'm going to put it over here, and let's see if I can fit it in so that my face doesn't cover everything. So let me remove everything that we have in code right now, like that. Okay, so we have only this, and I'm really sort of afraid that my face is going to cover everything. You know what we should do? I'm just going to take this and I'm just going to move it like this a little bit, because I still want you to have this concept in mind. You know, we have the base, we have the core, and we have the modifications. All right, so what we're going to do is we're finally going to define some cars. So we're going to have a final class Lamborghini, and I believe this is how you spell that, Lamborghini. Yeah. So we're going to override the model yet again. You know, the same as we did over here in this one. Like this one. Oh, I'll let it go. Come on. There we go. Okay, this should be enough. So we're overriding the model, and I forgot a column. Model, like this. So now we're going to say it extends a sports car, which in this case is core.sports car. And we're passing in the model, right? So even though we're overriding the model in the very abstract class, the sports car, it still has a constructor, right? So we're passing in the model, and now we're going to say with modification dot spoiler, and I'm just going to duplicate this line because it's also no, I'm actually not going to duplicate this line. We're gonna duplicate it for the next car. Let me see if it compiles. And yeah, it does. And let's create another car. So now we're gonna have an ordinary car, BMW. We're just gonna override the model string, and it extends core.ordinary car, passes the model in, and now it also has a spoiler. So it has a spoiler, modification dot spoiler. But it also has, and this is where I duplicate the line, it also has the engine control unit, and it also has the turbocharger, right? Everything still compiles. Okay, so I'm sorry for the jumping around, by the way. All right, so we have a Lamborghini and we have a BMW. They're final classes, so we can't extend them further. And by the way, I shouldn't be able to mix an engine control unit, for example, into a sports car, right? Because it says that it's an ordinary car. Let's just for fun try it. I'm not actually super sure. Yeah, so it's going to say it's not a what is it? It's an illegal inheritance superclass sports car, which is this one, is not a subclass of the superclass ordinary car of the mix and trade engine control unit. So because it's not here, we can't mix it into the sports car, right? We would need to have a sports car over here. So let me remove it again, like this. So now it compiles. Let me maximize it again. And so what we're going to do now is we're actually going to have a few print lines. We're going to print out new Lamborghini, and the model is going to be Murcielago, right? And the other one is going to be, in fact, you know, let's say, no, it's fine like this. So the other one is going to be the BMW, and the model is going to be M3 GTR. All right, and let's see what we're seeing here. We're seeing an exception. What are we seeing here? Malformed class name. Really? All right, so this is happening because, you know, in my preparation for this video, I didn't actually create those objects. And when we're saying get class, then it's actually, you know, the class name is going to be base $dot BMW in this case. So we're just going to do a full name. I think it's called full name, or maybe just get name. So instead of this, we're just going to say get name. Right? Okay. In fact, this actually looks kind of ugly. I thought we would just do this kind of cool. Let's just do this. Let's just go here and say, oh, we don't have the brand. Okay, so let's just do this. Let's just do def brand, which is a string. And now over here, also let's remove this brand. So I'm just gonna say brand which is a string. Let's also have an override. Gonna have an override def brand string equals Lamborghini, and we're gonna do the same thing over here with the BMW, like this. And now it probably complains because of the sports car and the ordinary car, right? So I'm just going to do this for now, just because it's an example. I'm just going to set the brand as empty. But you should never do this in production code, right? So this was just like on the fly. I really wanted it, you know, to make it look cool. So so I just did some copy paste, and as you can see, I already broke it. So over here it's a BMW. Okay, so the first one is a Lamborghini Murcielago, and look, in the beginning it had where is my sports car? There we go. So in the beginning, the top speed in kilometers per hour was only 300, but because a Lamborghini mixes in a spoiler, and a spoiler basically multiplies the 300 with 1.02, we're getting 306 out of it. In fact, we can actually try it. Let me interrupt this loop, and we're going to go into the console, and we're just going to scroll. Can I scroll down a little bit? No, I can't. All right, so I'm just going to do 300 times 1.02, and remember that it's a double, so we're going to do 2int, and if I did everything right, then we should see the 106. And if I scroll up, what happened to the BMW? We had 336, because the BMW, it started with 220, right? So let me go here. So it started with 220, and then it was multiplied with, hold up, okay, so we had the turbocharger, but the turbocharger only does something to the acceleration, so we can ignore it for now. So we have a spoiler and the engine control unit. So the spoiler, we already know it's 1.02, and then there is also the engine control unit, which is 1.5. So whoops, 1.5. So we should get 336. Yeah, and this is in fact exactly what we're getting with the BMW over here, 336. I'm not going to do the same calculation with the accelerations, because you know, you get the point. Okay, so let me press Control D. So now we're back in SPT again, and now let me do run, and we have our main again. All right, so let me mix it by Sublime again, and let's just talk about this a little bit more. So first of all, how does all of this work, right? Because it looks like multiple inheritance, but Scala, same as Java, doesn't actually have multiple inheritance. In fact, very few languages have multiple inheritance, right? First of all, why does it even look like multiple inheritance? Let's see. So for example, we have a BMW, and a BMW mixes, it extends an ordinary car, right? And it also mixed in the spoiler. But if we look at the spoiler extends the car, and an ordinary car also extends the car. So a BMW is already a car, and as soon as we mix in the spoiler, it's somehow a car again. So we should mix, so we should inherit from car twice, and this is the common problem with multiple inheritance, which languages like C++, for example, they have a special keyword for this, which is called virtual, which sort of solve this problem, right? So what happens in Scala is that there are two things that are happening. The first thing is that Scala will look at this, and it will put this whole inheritance hierarchy into an order, so into a one big list. And then what it will do is it will remove the duplicates. The official name for this concept is linearization. So as soon as Scala puts everything in order, you don't have diamonds that are that you typically have with the sort of the solution for multiple inheritance. You don't want to have diamonds because they're kind of hard to reason about. And also because after everything is put in order, the duplicates are removed, you also don't have multiple inheritance, which is something that you want, right? You don't want to extend things multiple times. Also, sort of as a sidebar, there's this concept of open recursion that I haven't really explained in this place because I didn't think that it was necessary, but it sort of keeps coming up all the time. And usually when you have a language which allows multiple inheritance, like for example in C++, then you inherit from multiple classes, which means that the calls to super methods, like this over here, so call to the methods that are defined on the base class, they can be statically resolved, which means every time you write this in a language like C++, you know exactly on which base class or on which class it will be called, whereas in Scala the supercalls are dynamically bound. They're bound later, right? So in fact, only when you say new BMW or new Lamborghini, this is the point in time where the whole linearization is happening, right? Because you can also say new Lamborghini and then you can say with something else, right? With some other trait. And now I'm typing on my face. All right, so basically at this point Scala linearizes the whole thing, so the supercalls are dynamically bound, which is sort of like a sidebar, so it's not really important. Okay, so how exactly does the linearization work? Which is, by the way, something that you don't have to know at this stage, but it's actually not as hard as you might think. So in order to understand that, we actually need to start talking about any. Remember in a few of my previous videos, I said that sometimes like when Scala can't resolve a type, then usually it resolves something like any, because anything can, any type in Scala is any. So it turns out that this is not some sort of compiler magic. It's simple inheritance. Every time you create a class, it automatically extends any. So the Scala compiler just inserts this extends any for you. In fact, you don't extend any directly, you extend any ref. Let me have a small example for this. So I'm not going to remove the current example, but I'm going to collapse everything to one file again, and I'm going to go to main, and I'm going to do 50-50 here, right? And we're going to have Sublime on the left again. Whoops, sorry, I took my entire VM like this. Oh, now everything is ruined. Okay, so let me put the terminal on the right. Let me put the Sublime on the left like this, and let me save the file once. Hold up, like this. Sorry for the whole jumping around. So now we have Sublime on the left and we have the terminal on the right, as we had in the beginning of this video. So what we're gonna do now is we're gonna just okay, first of all, let me remove the print lines. We're just gonna have a simple class called person, takes a name as a string. What happened here? Name, which is a string. Let me put the cursor over here. I'm starting to hate this cursor. So every time you do this, by default, you extend any ref. And for now, it doesn't really matter what methods are defined on any ref. In fact, it actually is a bit. It actually does matter a little bit. I'm going to explain this in a few seconds. So what you then can do is you can say print line. Let's actually create a person. So let's do Bob equals new person, right? And it's going to be Bob. So we can print out Bob.name. And now we can also print out the things that are defined on any ref, and this should be about, right? Okay, so now we can also use the methods that are defined on any ref. And as we've seen before, there are functions that there are members that are called something like get class, right? And get class shows you main person $1, and there's a get simple class, which shouldn't work now, right? Because we're in the same situation, I believe, with those dollars. No, it's not. What is it called? Get simple. Okay, so it's get class dot get simple name, right? Which also shouldn't work in this case. Yeah, so it's internal error malform class name, blah blah blah. So yeah, but we have get class. Right, and also every object has a toString. So in fact, every time we're doing this, we're actually doing toString. So we're calling toString on the string, we're calling toString on the class, and we can also call toString on Bob, right? So and every time we override toString, so we do override def toString, so the string equals la la la, and then this one will call it. This is simple inheritance. And as we already seen, like was anonymous classes, you can also do, so instead of saying new person Bob, what you can do is you can just do we can just remove that. So we can just do new, and then you have the body of this thing. So we're creating a class and we're creating an instance of this class, a single instance of this class at the same time. So we're going to do something like def name, which is string, which is Bob. And let's see if this still works. Yeah, it still works. So the class is like some weird anonymous class that says main $, and then the name of the class is $anon, and the name of the member is $1 somehow, right? And what it's doing is it's actually extending any ref, right? And again, I'm gonna have like a dedicated video for anonymous class because they're kind of important. So this is all we need for now for the whole of the whole Scala standard hierarchy. As I said, you know, in the separate video about anonymous classes, we're going to probably in this video, we're going to go, I mean, in that video, we're probably going to go through the whole, you know, hierarchy in detail. But for now, all we need to know is any ref and any, because right now we need to talk about linearization. So what we're going to do now is we're going to try to linearize BMW. So I'm just going to have a bunch of comments. So we're going to start with BMW, and it will be at the end of the line. So right now we're actually going to have like a bunch of spaces here, and we're going to see, okay, so it extends an ordinary car. So let's have an ordinary car, and an ordinary car, so basically going through the classes first. So an ordinary car, if we go to core, it extends a car. Okay, so it extends a car, and a car doesn't extend anything, and doesn't extend anything means that there's any ref, and let me make some sublime again, and then there's actually any, because any ref extends any. So this was sort of the simple part. This is going to be by the end of the hierarchy, right? So the next thing what's happening. The next thing what's happening is there's a spoiler. Let's have more space here. So we're going to have a spoiler somewhere here. Spoiler, right? And we're going to do the same thing with the spoiler. So we go to the spoiler modification. So we have a spoiler. It extends car. Okay. So we're going to do, you know, car. And the same thing. We already know that car, you know, just extends any ref, and it extends any. So this was the first step. This is the sort of the linearization step, and the second step is to remove the duplicates from the right. So we'll look here. Okay, we already have an any, we already have an any ref, we already have a car. So we basically just remove this, right? And then we do the same thing with the next one. So the next one is engine control unit, and then we just keep going like this, and we end up with this beautiful linearization. Engine control unit, and we're going to have a turbocharger over here. Yes. So this is the linearization, which defines the order in which the methods are going to be called, which can be important, by the way. Like in our case, it wasn't important. For example, a BMW that mixes a spoiler and an engine control unit should not be faster as a BMW that mixes an engine control unit and the spoiler. And later we're going to have, still in this video, we're going to have an example where the order actually matters. So in order to demonstrate that, let's actually go to everywhere. Let's go to the core, and let's have, in fact, let's actually start with the base. So this is the constructor for base, and we're just gonna say print line car over here, and then we're gonna go to core. We're gonna do in the constructor, we're gonna say print line ordinary car, and over here we're gonna say sports car. Right, sports car. Okay, and in the and now we're going to do the same thing for the implementation. So this is already in the implementation. So we're going to do just the top speed. Okay, in fact, let's not do the implementation yet. Let's go to the modification trace and keep doing this constructor pattern. So in the constructor, we're going to say print line spoiler, print line engine control unit, and also print line turbocharger. Okay, so now if we look at our main, which has the cars commented out, let's remove this whole Bob thing, right? So let's do the BMW. So we should see exactly what we have here. We see a BMW, right? Actually, we don't see the BMW. Why don't we see the BMW? Because we didn't add anything to the constructor of BMW. So let's do print line BMW. Okay, so this is still the print line of that, right? This over here, right? This is our toString. Then we see the BMW, then we see the turbocharger, then we see the engine control unit, then we see the spoiler, then we see the ordinary car, and then we see the car. And this is the linearization. Well, what does it mean for the method calls? Let's do the same trick. Print line, print line, print line, the old print line trick. So let's go to the implementations over here. Right, and we're going to say print line, and I'm going to do engine control unit dot top speed in kilometers per hour, and I'm just going to copy that, and we're going to go to the modifications. Oh yeah, we're already in modification. I thought we were at core. I wanted to go here first, over here. All right, so before returning the 300, let's do this, which is a sports car, And let's go to the other modification. This one is the only one that is left. Let's go here, add this print line. So in this case, it's a spoiler dot top speed in kilometers per hour. So it should mean that the spoiler, sorry, the engine control unit is called first, and then the spoiler is called. I actually kind of thought that the one from core is going to be called. Oh yeah, because I did it on the sports car, and the BMW is not a sports car. Let me move it over here. Let me do this. Oh, that's gonna be ugly. All right, like that, like that, like that, like that. And because I want to avoid confusion, let's just do a 300 over here, right? Like this. Okay, so this is what we see. So the first one that ends up being called, it's top to bottom, is the one on engine control unit. Why? Because it's at the top right. So this was the last modification. This was the last modification that triggered the whole line, right? So let's see. So if you go to main, we have our BMW over here. The last thing that we mix in that modifies the top speed. You remember the turbocharger does not modify the top speed. So if you go to so the last one to the right, it modifies the engine control unit. So what it's actually doing is the first thing that it's doing, it's doing this print line, and then it does the super call, right, to the next in line. And this is what I meant. You don't really know on which trait you're calling this, right? So what ends up happening is whatever is accumulated, whatever will be accumulated in this chain, when this chain is gonna, the chain of calls, when it's gonna come back in the end, the last thing is gonna be what's gonna happen is times 1.02, right? So this is gonna be actually the last thing that will happen because we wrote it like this, right? I mean, we could keep going, but basically it's clear now, right? So it's first this, then the spoiler, and then actually the thing that's on the sports car. And it's because of the way we wrote it. So we have control over the order by understanding how the linearization works, right? So if we switch them, right, if we switch spoiler and engine control unit, the results shouldn't change, right? Because the multiplication is a commutative operation, so the result is not going to change, but now the print lines are going to change. Now the racing game showed us how traits can be used to modify functionality, and our last category is going to be about how to intercept functionality. But before going there, I'm just going to have a super tiny example just to show you that the types are actually removed. So it's going to be simpler than the racing game example. So let me maximize that. So what we're going to have is we're going to have a trait, and we're going to have a class abstraction extends trait, right? And then we're going to have a class implementation. It extends abstraction, and now it mixes the trait in again. So now you see, now it's more obvious that the trait should be here twice, right? Because abstraction already extends trait. So basically, what if you would do like some sort of substitution, right, that then you would have something like this, extends trait with trait. So it's basically something like this, right? But in fact, because linearization is in place, it will still compile. Everything is fine. So Scala will remove one of these, and you already know which one is going to remove, right? The linearization order from the right is going to take the priority. The ones that are coming from the left are going to be removed. Another thing, just for fun, and in fact, this is a Stack Overflow question that I asked years ago. I asked, well then, if it works like this, then why can't I have trait 2, right? And I'm going to have a class 2. Why can't I say extends trait with trait? So if linearization would work, it should kick it out, right? It should kick one of them out and it should compile. But in fact, it doesn't. And I believe this is just intentional, right? So basically, when the compiler looks at this, it assumes that it's done by mistake. So it says, just remove it, okay? Yeah. But in theory, linearization should kick in and remove it. All right. So let me fix that. Let me just remove it actually. So we have our print line BMW, and in fact, what I should do now, probably I should go through all the constructors, because I don't want to remove this example. So I want to remove all the print lines instead. So I'm going to remove this print line. I'm going to go to core, remove this print line, and actually all of these, right? And let's see, so the last thing is here. So we still have something on the sports car, do we? All right, there we go. It's this one. let's do this. By the way, let's actually try to have a val somewhere here. I had issues with this, and you always you sometimes have issues with like initialization, or in this case, super may not be used on value top speed in kilometers per hour. So you can't call super if the super is a val. So just stick to defs. In general, by the way, if you have traits, try as much as possible only to use defs in them, even though it's something as simple as this, because it's clearly just an integer, right? It should be possible to just have it as a val. Still, for traits, for initialization reasons, use defs as much as possible. All right, so now we have only our last print line, which is this one, and I'm going to leave it for now. In fact, I'm going to leave both of them, and let me remove the linearization thing. All right, so we're back to our example. So now we're going to have an example with intercepting the API. Now, in the car example, our methods, the ones that we were overriding, they didn't have any parameters. So there's nothing to intercept, and in this example, we're actually going to have something to intercept. So our base is going to be Java util set from the Java API. So we're actually not going to define the base ourselves. What I'm going to do instead, I'm just going to say, okay, it's going to be Java util set, and what did I do? Java util set, and in this case, we're going to play around with strings. So because it's just a comment, everything should be fine, right? And our core. Again, we're not going to have the core. We're going to use a core from the Java standard library. In this case, it's going to be Java util hash set of string. And we don't really know how, what the difference is and how they work. So basically, all we need to know is that set is abstract, hash set is an implementation of set. So hash set extends set, right? We already know that the core has to extend the base. And our modifications are going to be like this. So let me just have a comment. Set example, right? So we're going to have a trait case ignorance. And by the way, we haven't talked about collections yet, but as of right now, I'm actually a collection is basically like a bag of things. So you can put things inside, you can remove them, you can see if they contain elements and something like this. So I'm not going to explain sets in this video. We're going to have a completely dedicated video to collections and to higher order functions on collections. So for now, all you need to know is basically a bag of data. So we're going to have a trait case ignorance, and it's going to be a modification for a Java util set of strings, and we're gonna have, what did I do here? Come on, like that. So as always, we're gonna have an abstract override def add. So there's a function called add on sets, and in this case, it's gonna be a string, right? And we're gonna call super.add, right? But before we're going to do two lower case. So we're going to convert the string to lower case letters, and only then we're going to add it to the set. Okay, and the other ones that we're going to override are going to, actually, let me see if it compiles. Yep, it does. All right, so the next thing is going to be override def contains. And the Java API is kind of old, so contains does not actually get the string as a parameter. It actually gets object in Java, which is Java's version of any, or to be more specific, any ref. But let's do any. So we're going to do any here, and now we're going to say super.contains. Let me remove the cursor. Super contains element, but we're going to have to convert it back to the string as instance of string, and then to lowercase, right? Because remember, this whole modification is about case ignorance, so we're going to ignore the case. Okay, and the last one is going to be, in fact, does it compile? It does. Lovely. So the other one is going to be abstract override def remove element any, also any again. It's going to be super.remove element dot as instance of string again, and as always to lower case. So everything should compile. Now we're going to have another one. It's going to be called logging, which is just going to do a bunch of print lines every time it's doing something. So it extends Java util set exactly the same way, right? And we're not going to touch contains this time, right? But we're still going to override the add, and we're going to override the remove, right? So I'm just going to duplicate that. So the add is going to do So first of all, it's going to print out add $E, right, string interpolation, and only then it will actually call add on super, right? And remove is going to do the same thing. It's going to do remove. It's going to do print line. Remove $. Why did I actually use E? I meant to use element. Sorry, element. And over here we're going to do $, or money sign element. All right, and now we're actually going to remove it. Super remove element. All right, so now it should be fine. So this example should demonstrate that the order actually matters. So let me remove those print lines. And let's have val first log, then ignore case, which is going to be equal to new Java util #set string, with case ignorance, and then was logging, right? So remember, the ones that are on the right, they're sort of first. So the first log, then ignore case. And the other one is going to be, let me actually copy that. So it's going to be first ignore case, then log, right? And we just need to swap these two. So in our example, what we're going to do is we're going to say first log, then ignore case, and we're going to call add, and we're going to add high. And what it should do is it should print out high, capitalized like this, and then, in fact, let me do this. Prints out add high, right? And the capitalization in this case is very important, and then adds high to set, right? And this one is going to do sort of the opposite, right? It's going to do first ignore case, then log, dot add high. So we're adding the same thing, right? But now the behavior should be different. So it's going to be adds high to the collection, and then prints out add. And notice that this time it's high, right? So actually, let's see that if what I said is actually correct. Login I found. Oh yeah, I put them into the modification thing. All right, so modification. So I'm gonna do this and this and this, and over here. There we go. All right, so at least the printouts are correct, right? So we have add high, which is capitalized like this, and this one is completely lowercase. And the last thing we're going to do is we're going to test the contains method. So we're going to print out, let me scroll down a little bit like this. So we're just going to print out first log, then ignore case, contains, and we're going to do high with a small I, and first ignore case, then log, contains, and we're going to reverse the capitalization, and it should say true. Now this is kind of cool. You have so much flexibility, so much modularity. So you have this Java util set, right? And you have two modification traits, right? So if you had only one, you would have basically only two options, right? You either mix it in or you don't mix it in. But as soon as you have two, and as soon as you can have two in a different order, you can have 5 different versions, which is a super modular thing. Code reuse works perfectly like a charm without multiple inheritance and anything like that. It's a really cool pattern. Just remember like one thing, that each one of those modification traits, it has the power to interrupt the whole chain of calls, right? So if we go to any modification traits, it doesn't have to call super, right? So it can interrupt the entire chain. That's like just one of the things to keep in mind. The very last thing that I'm going to show you in this video is a very cool trait called app. So what you can do is you can go to our main and we can extend app, right? So the main extends app, and what it does is it defines the main method for us. So it works in such a way that everything in our constructor is just going to be run automatically, so we don't have to define main ourselves. So we're just going to remove the main, we're going to indent it like this, and it's still going to work. right? And the other thing that it brings with itself is, so it obviously has the access to arguments, and it also has access to execution start. So if you go here, I'm going to go print line execution start, which gives you the milliseconds since the beginning of time in programming. And the beginning of time in programming is January 1st, 1970, which is something that every programmer should know. And if you want to actually convert it to a date, then the way you do this, at least with the old API, which somehow, sometimes it's actually better than the new API, you just pass it in, right? So now you see the date and the current time, which is correct. All right, this was the very, very last thing, and I hope you enjoyed this video. Traits are really, really super cool, but please remember that most developers, they make this mistake of every time they discover a new framework or a new tool or a new pattern, they look at this as this very, very new shiny hammer, and they go around and try to find some nails. Just always remember, even though it's cool, it's just a tool. So if you have a use case, use it. If not, then don't try to shove it into everyone else's throats. All right, that's it for today. It's been Vlad, devinsider.com. I hope you liked the video. Subscribe if you're new here and if you want to improve the developer inside you. And most importantly, take care.